So in the last lecture we discussed the five sentences, that negation statement, uh, conjunction statement, disjunction statement, conditional statement, biconditional statement. Okay. For the negation statement, we have, if the statement is true, then negation statement false. Statement is false, negation statement is true. In a conjunction, we have P. The conjunction, we have P and Q. So the conjunction is a true only if both statements are true. If any one is a false or both are false, conjunction is false. Then we have disjunction, that is a P or Q. It is read as a P or Q, denoted by this way. And disjunction, it is a false only if both are false. If any one is a true or both are true, then disjunction is true. Then we have conditional statement. In a conditional statement, when we have conditional statement, in conditional statement, it is denoted by P implies Q. Okay. It is the conditional statement is a false only if P is true and Q is a false. Otherwise, it is a true. So if first statement is false, the conditional statement is a true. Or both statements are true, then also it is a true. Okay. Then biconditional statement. The biconditional statement is P if and only if Q. The P if and only if Q, we have the when both statements have a same value, the conditional statement is a biconditional statement is true. If both has a different value, means one is a true and second is a false, or first one is a false and second is a true, it is a false. So we have this five statements. Okay. The first one is a negation of P, that is a negation statement, conjunction statement, disjunction statement, conditional statement, and biconditional statement. Now, then we have the definition of tautology. The tautology means a compound statement is called tautology if it is true for all values of involved statement. Okay, means no matter that involved statement is a true or false, the compound statement is always true, then that compound statement is called tautology. If compound statement is always false, no matter with true or false of the involving statement, then that compound statement is called contradiction. And if both true and false, it is called contingency. Okay, so this much we have done. Screen is visible or not? Hello. Okay. Now, next we have logical equivalence. In a logical equivalence, here two statements A and B, that A and B are called logically equivalent. A, the A if and only if B, the biconditional statement, A if and only if B is a, this statement is this statement is a tautology. Yes. So we have the A, two statements are called logically equivalent. A, if we make the statement this, P if and only if Q is a tautology. Okay. A P if and only if Q is a tautology, the P and Q are logically equivalent and it is denoted by this notation. This is notation for the logical equivalent. Okay. Here, if we talk about the A and B, then it is a A equivalent to B. Okay. This way we can um, express the logical equivalence. Okay. Now we use this logical equivalence to prove the some theorem. The we have the first theorem is a De Morgan's law. So what is a De Morgan's law? If we have the two statements are given P and Q, then the this one, then we have these two statements of the De Morgan's law. One is a negation of P or Q. It is equivalent to negation of P and negation of Q. The second one is a negation of P and Q. It is equivalent to the negation of P or negation of Q. So to prove this theorem, we use the truth table. Here we prove this theorem by truth table. Okay, and here let this, suppose to prove this first one, then we make the statement here negation of P or Q the negation of P or Q if and only if the second statement B negation of P and negation of Q. This to show both statements are equivalent, we have to prove the if and only if statement is a tautology. So first we make the if and only if statement and then we derive the truth table, and using truth table we prove that this is a tautology. So both statements are equivalent. Okay. So here, derive the truth table for first one. So here to prove this one, you have to here you have to make the table. The columns are P, Q, P or R, P or Q, negation of P or Q, this is A, then negation of P, negation of Q, then negation of P and negation of Q, that is a B. At the last, we have A equivalent to B. That means you have to take A if and only if B. Okay, to prove that A equivalent to B, we take A if and only if B. So derive this table and write in chat box that it is a tautology or not. Derive the truth table and then write it is a tautology or not. Then Rahul, Swati, and yes, it is a tautology. So we have this table. This here P, then Q, P or Q. So in P or Q, both are false. Then we have false. Otherwise, we have true. Means both are true. Then true. If any one is a true, we have true here. Okay. So we got T, 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 S. Now negation of P or Q. So here, whenever we have T, okay, we replace the T by F and F by T. So first we three have F, we got first three F and fourth one is a T. Now negation of P, so here first two are T and second two are F. So here first two F and second two T. Okay. Negation Q, here we have alternative TF, TF. So here also alternative FT, FT. Okay. Then negation P and negation Q. So it is a true, only both are true. It is in a last row. Here we have true. This is also true. Okay. Both are true here. So we have here true. And remaining places we have false. If we compare these two columns, this is a and this is B. Then for binomial, here we have A, if and only if B. Here, no, do not write this way. Okay, you can write this way also. This is also true. But first write the statement A, if and only if B. Now here, if both have same value, we have C. If both have different value, we have S. So here we have first three are S and fourth one is C. Here also first three are S and fourth one is C. So both have a same value in a row. So we have all row are C. Okay. So this is a tautology. So A equivalent to B. That means we prove the theorem. Okay. Now similarly, true for the second one. Just true for a second one. Yes. This one is So here you have to prove negation of P and Q if and only if negation of P or negation of Q. Okay. Now to prove this statement is a tautology. So if you make the table, it is like this. Here in place of A equivalent way, you can write here A is can only B, and here this is the A, this is B. In A and B at in a all row they have same values, so biconditional statement is tautology. So A is equivalent to B. It is through the theorem. Okay. In this theorem, you have to just make the table, and at the end you have to just write the statement again that here is the statement is a tautology, so that A equivalent to B. Okay. Then we have next theorem. associative law. Okay, here question will be asked that state and prove associative law, or state and prove De Morgan's law, or state and prove assumption law. Okay, so you have to just remember statement also here. So you can prove by the truth table. Okay, so this is a statement for the associative law that if we have two statements P and Q are given, then P or Q or R, it is equivalent to P or Q or R. Similarly, for AND operator also, that P and Q and R, it is equivalent to P and Q and R. Just so to prove this one, we use the again truth table. So to prove this one, the first one, we have to make the sentence here P or Q or R if and only if P or Q or R. This you have to prove that this statement is tautology. So derive the table. जिसका टेबल बन गया वो एक बार चेक कर लेना, राइट है कि रॉन्ग. So this is a tautology. Okay. Similarly, you can do the second one with an AND operator. Just check this table. Using this way, we can do the second option. Okay. Remember that in a truth table, when we have the uh, three statement, we use the arrangement. In a first statement, we take first four are T, next four are false. In a second statement, we use the arrangement first two, three, second two false, then again two times T, then again two false. In a third statement, we take alternative CF, 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 CF. Yes, we use this arrangement for the three statements. Just check the table, and if you done, then write in a chat box. Then जिसका खत्म हो गया वो डाल लिख देना chat box में. तो अभी तक किसी का नहीं बना. दो जन का आया. Okay. Okay, then the third law, the third theorem is the absorption law. The absorption law is if we have P and Q, two statements are given. P and Q, two statements, then the absorption law is given by P and P or Q. It is equivalent to P. P or P and Q, it is equivalent to P. Okay. So to prove this one, we use the same method to make the two tables for these two statements and prove that it is a tautology. Okay. Milan, Tom, Madu, Ian, Clinton, yes. Okay. संदर्भ का हो गया. So just check your table. Just check your table. These two are tables to prove the assumption law. Okay. Then we have the exercise here. So here you have to prove the first one. It is a tautology. So make the table of two statements. In the first one here, is in the first statement, you have the columns are P, Q, negation P, negation Q, then P implies Q, then P implies Q, and negation of Q. Denote this one by A. Okay. So the last column is A implies negation of Q. To check it is a tautology or not. Make this table. Okay. Anjali. Okay. Anjali, okay. Then okay. Then here for the second, okay, most of have done the first. Now in second, here in a second, P and Q, so conjunction. In a conjunction, we have the first, when both are true, it is a true. Remaining three options, it is a false. Okay, in conjunction. In disjunction, the first three are true, and the last one is a false. Okay. Now this is a conditional statement between these two. So in a conditional statement, the first is true and second is false. Then we have conditional statement is false. Otherwise, it is a true. So in a first one, it is a it is both are true. So we have true, and then the last three, then the three are false. The first statement is false. When first statement is false, conditional statement is always true. No need to check the second statement. Sorry. So the conditional statement is a true when the first one is a false. First statement is false. This, so this is also a tautology. Now, in a third question, where in place of so that, we have to just change this. In place of so that, we have uh, checked the following statements are equivalent or not. Okay. In place of so that, we just check the following statement are equivalent or not. Okay. So the first we have this A is given P implies Q implies R. B is given B, P and Q implies R. So to check the A equivalent to B here, to check A equivalent to B here, where we have A is a P implies Q implies R and B is a P and Q implies R. Okay. So here, now to prove this A equivalent to B, we make a table P, Q, then R, then P implies Q, then A means we have P implies Q implies R. So this is the A. Then we have P and Q. Then P and Q implies R. So this is a B. And the last one is a if and only is B. Okay. We have this is our table. Now for P we take first 4T, then 4F, here 2 times T, 2F, again 2F, here TF, 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 TF. So P implies Q. So when P is true, Q is false, then we have false. It is happen only at the third place and at the second place and at the third place. Okay, where the third and fourth place, not on second place. At third place and fourth place, the P is true and Q is false. Remaining option, there is not this type of the pair. So P implies Q is a first 2T, then 2F, then 4T. Now P implies Q implies R. So this is the first statement. This is first statement and this is the second statement. So here we have this true, true, so here true. In second, this is true, this is false, so here we have false. Then two false, so no need to check the R, we can write directly true. Now here T, 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 F, T, 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 F. In this, it is a for both are true, so we have true. In six, T, F, so we have F. Here T, here T, F. Okay. P and Q. So P and Q is a P, T, F, 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 F. Okay, P and Q. Now P and Q implies R. So the first two, we have to just check this two. Remaining are F, so no need to check R. We can write directly true. So here in our first two, in R we have first is a true, second is a false. So this is a first is a true, second is a false. Then here we have 6F, so here we have 6C. Okay. Now if you compare the A and B, then at the 6 and 8 entries, they have different values. Remaining all places, they have the same value. So at A double implies B, we have T, 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 F, T, F. This, so this way, here we got a contingency, not tautology. So here A double implies B is a contingency, it is not tautology. So A is not equivalent to B. At the end, A is not equivalent to B. Okay. Okay. Now similar way, check the second and third. Similar way, check second and third. The given statement A and B are equivalent or not. Check the second and third. What about in a second? What about the second? It is A and B are equivalent or not? Hello? What about the second? A and B are equivalent or not? If it is equivalent, uh, Aziz,
Yes, sir.
चेक करो इक्विवेलेंट आएगा या
Okay,
तो
sir.
फिर अपनी स्क्रीन डिस्प्ले करो तो मैं देख लेता हूँ.
Yes, sir.
Okay, so most of got the equivalent. अजीज हो गया? Okay. So third one is also the equivalent. In third one, we have just two statements, P and Q. So you have to make the only in third, we have P, Q, P if and only Q. I'm not writing the column P and Q. Okay, I'm just writing directly. So the column P if and only Q. It is a T, F, F, T. Then here P implies Q. So P implies Q. It is a T, F, then T, T. Then Q implies P, where Q implies P. It is a first Q is T, T is T. So we have T. Q is false, so it is true. Then Q is a T, but T is false, so here third is a false, and fourth again Q. Okay, so this is a Q implies P. So the OR statement of P implies Q, the OR statement of P implies Q, it is a all T. So A and B are not equivalent because in A, middle two are S, in B, all are T. If we take the biconditional statement of A and B, then it has middle two are S and first and fourth are C. So it is not tautology, it is a contingency, so A and B are not equivalent. Okay. Suppose here in place of or statement, here in place of this or statement, if and statement is given, then what happens? If and statement is given, then here you have T, so here you got T, here you have F, here T, so F and T, you got here F. Here T, F, so here you got F. Here again T, so T. So when you check the A and B, both have a same values in each row. Therefore, A and B, A if and only B is a tautology, and therefore A and B are become equivalent. Okay. So in place of or, if we change the operator only, we change the or by and, then we got the statements are equivalent. Okay. In examination, just take it carefully. Okay. So here the next we have the verification of validity of argument. So what is the argument? Mostly the argument is given as the mostly argument it is given by this way. Okay. The there there this is a A1, where this is a A1, A2, similar way A3, then A4 up to AN. These are the arguments. And therefore AN. The AN is called conclusion. Okay. So if the argument is given in this form, that this argument, the whole expression is called the argument. Okay. So if we have given in this form argument, the first A1, A2 up to AN minus 1, and the conclusion AN. If these arguments are given, then to check that it is a valid or not, we make this statement, this A1 and A2 and A3 and up to the and AN minus 1 implies AN. Where we make this statement, and if this statement is a tautology, then given argument is called valid. If it is not tautology, then given argument is called not valid. Okay. So to check validation of the argument, we use the truth table. So now we have the some non-arguments. The first one is a method of affirming. So in method of affirming, here we have here in method of affirming, we have the in an examination. Mostly this argument is given as P implies Q, then here P, and here therefore Q. Okay, there is no need to here the A1, A2, A3. It is given for your understanding. It is not given in an examination. Okay. So mostly examination, the arguments are expressed as this way, or in a some books they are expressing this way. Okay, they just um, make the one straight line between the conclusion and argument. Okay, if this type of argument is given, now to check the it is a valid or not, the before the conclusion we use this P implies Q and P. We take this two in a AND statement. This two we write in a AND statement. Okay, these two are in AND statement, and then this Q in a conditional statement. First two in AND statement, and this is a in a conditional statement. Now, if we check the table here, then see this is a table. So here see P Q, P implies Q, then P implies Q and P, and then last we have this statement P implies Q and P implies Q. Okay. Now here, if we have P is a true, in a P we take P T F F, in Q we take T F T F. So P implies Q. So it is a false only if P is T and Q is X. So here we have F remaining 3 true. Then and P, so we have to compare the first and third column, and we take the and statement. So whenever both are true, we write true. If anyone is a false, we write false. So here in a second, the P implies Q is false, and in third and fourth, P is false. So these three we have false, and first one is a true because both are true here. Okay. Then implies Q. When we take the implies Q, here we compare the second and fourth column. So in our fourth column is a first statement, and second column is a second statement. In our first statement, the first one is a true. In second statement, first one is a true. So we get true. Now remaining three in our first statement are false. So no need to check Q. You can write directly C. Okay. So this is a tautology. So the given argument is valid argument. Okay. So this way we prove the argument that it is a valid or not. Now second we have method of dining. Sorry, dining. Now here make the truth table and prove that it is a valid or not. You have to write in a set box after completing the truth table. You have to write that it is valid or not. Okay, your conclusion is a negation C, and two arguments are where these two are arguments. P implies Q and negation of Q. This is a negation of P. It is a conclusion. So we write the statement P implies Q and negation Q. Whole implies P negation P. Okay. We check this statement. So we write the truth table. Check it is a Okay, Rahul got answer. Just check the table और जो लोग बीच में रुक गए हो जिसको समझ में ना आया वो टेबल चेक कर लो. Okay, so this way we can prove the argument is valid or not. Now we take the argument in a quick statement. Is it done? And this is the third one. Dilemma is here. So here we have a three argument and one conclusion. Okay. So here we have the table is a to prove this one we make this statement. Here we have one bracket is required. Here we have this. Here we have one bracket. This. So to got this, you can do it this way. Now see here, um, in the here, see this x intersection y means x and y and z. The x means this is a x, this is x, this is y, and this is z. Since we are taking the two statements with a one operator, but here we take the three statements with an operator. So here both operators are same, both are and, so we can write the directly the value of x and y and z. Okay. Otherwise, if both are different, then you have to take the first two with an operator, then the solution, and the third one with operator. Okay. So when we take the directly here, the all three are true, then we have a true. If anyone is a false, we have false. Okay. So here see in the first row, all three are true. So we have true. In second row, y and z are false. So we have false. Again, third row, all three are true. So we have true. In fourth row, y is false only. X and z are true. Then also we have false. Okay. So similar way, 5, 6, 7, and 8. If all three are true, then we have true. If anyone or more than one are false, we have false. Okay. So Then A is a, we have A means this X and Y. This is a A, this is A, and B means R. Okay? B is a R. So A implies B. So the second last column we take as a first statement and third column we take as a second statement. So whenever we have where we have the false statement in a second last column, where we write the true because we have the conditional statement. Okay. So here for this false, this, this, and this. There is no need to check R. You can write directly true. Okay. Then for the first one, the A is true, B is true, so we get true. For a third one again, A is true, B is true, so we have true. Fifth one, A is true, B is true, so we have true. Okay, we got all three, therefore the argument is valid. Okay, now similarly, the fourth one, hypothetical syllogism. So in hypothetical syllogism, here the same way we make this statement. Okay, this statement, and we got this table. Okay, so this way we can prove that this this argument is a valid. Check the table. Now you have to practice for this one. Check these are valid or not. Check these are valid or not. First and second. Here we have the disjunction synonym. We have two arguments here. So check the both arguments are valid or not. And we have to write the answer in a chat box.